Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we'll look at resistor color coding so that you can find out what the value of a resistor you have. In the first couple of labs that we do with hands-on, what we're going to do is we're going to actually just do some things with simple resistors, measure voltages across the resistors, and see. We'll do a single resistor with a battery. We'll do two resistors in series, two resistors in parallel, and look at it. So we need to know how to tell when we look at a resistor what its value is. With resistors, they come in different types, and the different kinds of resistors have different numbers of bands for their color code, and then they've got different colors on the resistor that will tell you the size. There are 4, 5, and 6 band color codes. Most of the time, you're going to see the 4 band and maybe the 5 band. You don't see the 6 band very often. In the 4 band resistor, the color code, the first and second bands indicate the resistor value, and the third band is a multiplier to tell you the overall size. In the 5 band, the first 3 indicate the value, and then the fourth is the again the multiplier. You have also a band that is the tolerance, and that tells you how accurate they are, whether that measurement is designed within, say, plus or minus 10% of the value, or 1% or 2%. And then on the 6 band, there's also a temperature coefficient, and unless you're dealing with some applications that are really highly critical, you probably won't see that 6 band resistor. So those tell us the resistance. A couple of other things about resistors is, we said before, the measurement of a resistance is in ohms, and some resistors will be in the tens or hundreds of ohms, but we'll see a kiloohm or a k-ohm. The kiloohm is 1,000 ohms. So if I have a 3 kiloohm resistor, that's 3,000. And then there will be mega ohms, which is million. A million ohm resistor. So if you've got a mega ohm, that's a million. And that multiplier will tell us what those values are. If we look at this first resistor, the first band is red, so you go down on the red, and that's a 2. The second band is green, so you go in the second band and look at the green, and that's a 5. And the third band is orange, and because this is a 4 band, that's the multiplier. So if you look at the orange multiplier, that's K. So this would be a 25 kiloohm resistor. Now, in the band, the color coding for those bands, for the values of the resistors, know whether it's first, second, or third digit, it's the same color coding on it, so you don't have to memorize a different sequence there. And most of the time, the resistors are going to start at the 1 ohm range, that black as the multiplier. And if you notice there, the numbering goes the same way, or the color goes the same: black, brown, red, orange. So, and each one of those is an increase by a factor of 10. So 1, 10, 100, 1,000, 10,000, 100,000, and so on. So if you can remember that color sequence, then you shouldn't have any problems with remembering or figuring out what the resistor values are. So you might want to memorize or at least learn those color sequence. Now, in the wonderful day of the internet, as long as you've got internet connections, you can look up the color coding and find out what the resistances are. Now, we are going to work typically with resistors somewhere in the range of from about 100 ohms to 1 kilo ohm in our values. And if we're using a 5-volt power source, then if you remember, the current is equal to the voltage divided by the resistance. Then if the voltage is 5 volts and the resistance is 1 kilo ohm, then this would be 0.005 amps or 5 milliamps. And what you will see is the amperages that we're going to work with are going to be very small. We're working with 5-volt batteries. 5 milliamps or less very often, certainly no bigger than a couple hundredths of an amp for the maximum current. If we start getting into currents more than about a hundredth of an amp, a couple hundredths of an amp, you could actually start getting the point you could hurt yourself if you got a shock with that. It's not really the voltage that hurts you, it's the current. But a lower voltage, that's lower pressure, you're not going to have the ability to typically generate a very, very high current. So as we start in the next few videos and start looking at our circuits and building some simple circuits, we want to build some simple circuits with resistors before we get into the actual digital circuits. Just keep that in mind. And I'd like to thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future videos. Please check out and subscribe to our other playlists on the Dan on Tech channel.